Good morning, welcome to AP Computer Science A, and we know that A is for amazing. So today we are going to be covering section 1.5, and 1.5 we all know that deals with modular division because all of you guys have your notes right next to you. So it's going to be a short lesson for today. So let's go over the reference. So at this point you should have your notes, and you should also have the replet ready for you to code. So make sure that you guys are coding along with me so you guys can retain some of the information and you'll be able to answer some of the questions I'll be done through a puzzle. So let me make myself smaller. There we go. So now, last section on 1.4, we learned that we can multiply, we can add, we can subtract, and we can divide. And there was another operation that we didn't cover. It was listed on your notes. It was called the modulus. So that's what we're going to cover today. So in computer science, if we have an integer, int, let's go and say x equal to 9, then we know that in that one statement we're doing two things. We are declaring and we are initializing the variable x. Correct? We can do it in two different steps, just like we've done it before, but now we want to be able to move where we just do it in one step, much more cleaner. And let's say we have x, int y equal to 2. Once again, we're going to declare it and we're going to initialize it in the same statement. And if we do int z equal to 9 mod x mod y, what would that give me? If I print system.out.print ln, we're gonna say the number z equals so therefore if I click on run, it's going to compile it and then it's going to run it. So I want you guys to be able to be aware that in this case we run it and there's a system error. So just in case you have a system error, then what was my mistake? Can you find my mistake? Type it up. Yes, Diaz forgot the Z. Correct? There's missing a variable in here. So let's try again. And what type of error is that? That's called a syntax error. Let's go and run again, and the answer should be 1. So modulus is just like you guys covered back, it's a division. Well, not division, it's the remainder of a division. So modulus is the remainder of the division. So therefore, back in when did you guys learn division? Was it 7th grade? 6th grade? Let's say 7th grade. So back in 7th grade, you guys learned that if you divide 9 divided by 2, we're going to place 9 divided by 2. 2 goes into 9 how many times? 4 times. 4 times 2 is 8. And subtract gives us 1. So therefore, this is your remainder. And you won't be able to write down somewhere in your notes. So that is what it gives you. So let's try just some more simple coding. We're going to simplify this a little bit more. So that's what's going to give us. So now let's go and get rid of lines 15. Let's go and get rid of lines 16 and 17 so we can simplify our conversation a little more. So therefore, what if I do z is equal to 20 mod 6? What will be the number z equal to? Type it up. What do you think it will be? That'll be 20 divided by 6 is 3. But what is the remainder? 2. Very good. So that's always going to give us the remainder. And even if we can do a huge number, 203 divided by, not divided by, but modulus 2, what will that be? Correct. That'll be 1. So later on in the next unit, we are going to use modulus to be able to determine if a number is even or odd. So that's one of the great uses of modulus. Beyond other ones that you guys will be coding today or tomorrow or the day after. So in this case, what if I do 20 mod 2? 20 is an even number. So it's going to give me 0. So therefore, we can use modulus to be able to determine if a number is odd or even. So go ahead and try other numbers. Try an even number. Try 2086. Will there be a remainder? Well, the remainder will be 0 because that's an even number. So that's something that you want to be able to keep in mind. And that's something that we mentioned on your notes. Correct. And if I say 5, or then that's going to be, the number will be, it's an odd number, so give us 1. So modulus is also used to be able to determine whether a number is odd or even. Now let's go into a little more simple example. Let's go and go through here. And let's go and say modulus, if we do, we've gone over some of those numbers. So 20 modulus 4. Or let's go, bigger number, let's go 7. What's 20 modulus 7? 20 modulus 7 will be, well, 20 divided by 7 is 2. That 2 times 7 is 14. So therefore, your remainder is 6. Excellent. Now, one of the other things that you have to keep in mind is that if you by any chance that number is smaller, such as 5 modulus 7, what do you think 5 modulus 7 is? Think about it. What's 5 modulus 7? So 5 divided by 7. 7 goes into 5? None. So the remainder is 5. So whenever you have a number that's smaller, modulus than the next one, they'll give you the number. So even if I do 4, 4 modulus 7 will give me 4, because 7 doesn't go into 4, so therefore you still have 4 as a remainder. And if I do 3, it'll be the same way. Last thing that I need to be able to cover is that do 3 modulus 0, it will compile, but what do you think it's going to give me? Yes, it's going to give me an arithmetic exception. You cannot divide by 0. Your math teachers told you that that was undefined. So therefore, you cannot do modulus 0 either. So you cannot do divide by 0, and you cannot do modulus 0. Now, it will compile, but what type of error is it going to give you? It's going to give you a runtime error. And then we'll go into more logical errors as we go into some of the coding. So we have syntax errors, logical errors, and runtime errors. So keep in mind, there's one more thing that I want to be able to point out to you guys. And let's go over to your notes. And on the left-hand side, I typed this up. So let's try this. So I want you guys to be, let me make myself bigger, because this is so important that I'm gonna make myself huge. That this is something that you guys will be using over and over again as you guys code. So this is something that you guys want to be able to highlight, place a tab on it, because you guys will be using it over and over again with some of the more logical programming that you guys will be doing. That's going to require not just knowing how to code, but having those critical thinking skills. So what if I do, so let's try some of those coding exercises. And let me make myself smaller. So therefore, if I type in $600, or what was the number that I typed in before? Let's use the same numbers, and then we can vary up if we want. 7623. If we do mod 10, that means that we're just going to chop off the first number, because 7,623 divided by 10 will give me, ideally, it should be 762.3, correct? So it goes 762 times, and the remainder will be 3. And if we do it by 100, that means that we're going to just keep the last 2 digits. So therefore, that will give me 7,623 divided by 100 will be 76 times, and the remainder will be 23. If I divide by 1,000, then 7,623 divided by 1,000 will be 7, and the remainder will be 623. So that's something to keep in mind. The one that you guys probably will be using and allow the exercises will be modulus 10, because that will give you the last digit, which is 3. So on some of the exercises that you guys are going to be working on, you guys are going to be using this here, and you'll be using, let's go up, 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 in combination of this right here. And that's why I even place the same numbers. So I want you guys to be able to think about this section and this section, and you guys are going to be using the combination of both to code some of your exercises. Excellent. So have a great day. Email me if you have any questions, and I will see you guys next time. Good morning. Welcome to AP Computer Science A, and A is for Advanced. Today we are going to be coding section 1.6, and you guys know that's 1.6 because all of you guys have your notes with you, and you also have gone into the Replit classroom and have access to the coding along activity. Just make sure that you guys are coding along with me, so that way you guys can retain some of the information that we're going to cover. Now today we are going to cover something that we actually talked about in section 1.4, which was numeric operations. So let's go through some of the things that we talked about then. Let's go and declare a variable x, and remember the difference between declaring a variable and initializing the variable. In this case, we are declaring the variable, and now quick thing, if by any chance you don't have your this part, go into the little 3 dots and go all the way down. If it's auto fill in some of this code for you, just go and disable it. You don't need it at this time in the class. It's a little distracting, and you'll be using it later on, but for now let's go and keep it basic. Now, so we declare it, and now we are going to initialize it. So x is equal to 9, and we initialize the variable. And now let's go get another variable. Let's go and make a variable y. That sounds great. Great suggestion. And now we're going to declare it and we're going to initialize it at the same time. Let's make it equal to 2. Remember, we've been talking about this, the difference between both of them. And why have we been talking about both? Because this will be on your test. You need to know the difference between declaring the variable and initializing. Or now we want to be able to do both of them at the same time, right? This is my preferred way to be able to do both. You can still do it this way, but that was more introduction. And there's a reason why, because once we go into memory allocation, we can discuss what happens, and which will be very interesting. But for now, I prefer if you do it the second way. And one of the things that we talked about was if we divide. So let's say I have n z equal to x divided by y, which is 9 divided by 2. And now let's go do a system.out.print. Let's go and print system.out.print ln. We're going to say the number z is equal to plus. What is the action when we connect two strings together? It's concatenate. And I know what you're saying, hold on, Diaz. You say concatenate two strings. Well, Java is going to be connecting those, this going to convert this to a string, and it's going to concatenate with the literal string, or the string literal, the number z equal to. And let me not forget my, but just be careful, that is concatenate. And we can concatenate a string using the print statement, but for now, just think about concatenate. Don't worry about the rest too much. And now if I run, it's going to be 4, right? We expect it to be 4.5. But at this point, we know that's not 4. Why? It's not 4.5, it's 4. So why is it 4.5? That is the question. We need it to be 4.5, but it's 4. Remember that Java is going to evaluate this, that's an int divided by an int. It's going to allocate int memory, which is only 32 bits, which is not going to have space for the decimal. So it cuts it off. So now it's 4 instead of 4.5. And then some of you guys will say, well, oh, hold on, can I just go and replace the int with a double? It will not work. What do you think? No, that's going to give you 4.0 because it's going to get rid of the decimal. By the time you want to store into a double, it's going to convert it to a double. 4 is an integer, 4.0 is a double. So therefore, how do we fix it? We learned that we can fix it by placing it 1.0 times. Because Java is going to perform this operation first. A double times an integer is going to store into a double. Then you're going to divide the double by an integer, it's going to still be a double, and then you can store into a double. So therefore, if I run this, this will be 4.5, which is what we wanted. Now, remember that we talked about that there were two different ways to be able to achieve this, to accomplish this. That's one way, and you can still do it that way. But now, because I know that all of you guys are advanced, that we can actually do it in a different way. We're going to be casting it, what we call casting it. So what we're going to place, we want it to make it into a double. So therefore, I'll place parentheses. I'm going to type in double. And what happens here is that Java is going to make the x into a double right away. So therefore, whenever Java makes the x into a double, it's going to be a, so it's going to make that into a double. And then a double divided by an integer is going to be a double, and then we're fine. So that process is called casting it. You are going to cast the value. Now be careful, because some of you guys might say, so let's go and run it. Did I run it already? Let's see, let's run it, let's run it, let's run it. And that's going to give me 4.5. So that works. Some of you guys might start doing the following. Some of you guys might start doing as follows. And so will that give me the same result? Yes or no? What do you think? That's going to give me a no. Because in this case, your order of operations, you are dividing two integers together, so it's going to be stored in an integer, and then once you cast it, you already lost the decimal place. So therefore, you want to make sure, undo, undo, undo. You want to make sure that you just place it, because you want to convert the x to a double, and then you can divide it up. So that is casting, and casting can be different, used in different ways. So we can cast an integer to a double, and that's going to give us a double. But let's go and go through another example. We're going to keep the z, and we're going to get rid of everything else. So therefore, this is a double. We are going to make it into an integer. So let's say we have int z is equal to 4.5, and I run it. What do you think is going to happen? What do you think is going to happen if I run it? I'm trying to store a double into an integer. It's going to give me error. Now very carefully, it says incompatible types possible loss conversion from a double to an int. Because the double is 64 bits, it doesn't fit into a 32-bit space. So therefore we cannot do it. But if by any chance you do have it, so let's go and say we do have int x equal to 4.5, and we want to be able to store, or let's say another error, right? So we want it to be a double double x equal to 4.5. That is correct, right? 4.5 is a double. We can store it into a double, 64-bit into 64-bit. But now we want to be able to store x into z. We know that that's not possible, and we want to be able to convert it to an integer, so we're going to cast it. That means that Java is going to convert the 4.5 into an integer. So what's going to happen? What's going to be the value of z now? The value of z is going to be error. Well, that should work. What's going on? DS semicolon. Well, you probably saw that. So let's run it. There you go. So therefore, whenever you cast a double as an integer, you're going to chop off the decimal place. So that's going to be very useful when you program and in some of the calling activities that you will have. So if I do 4.9 and 4.9 is a double and I cast as an integer, it's going to be 4.999999999, and I'll cast as an integer. It's a double, and I'll cast as an integer. It's going to be 4.999. You guys get the point, right? I can continue on forever. So therefore, another way, let's say I want to be able to get, well, I'll let you guys think about that for the calling activity. I don't want to give too much away. We can also, if you notice on your notes, and we're going to come back to casting once we even go into objects but that'll be not to unit 5. We're going to come back to that in a second. So read through your notes. Notice that we went over how, let me make myself a little larger. We went over what that causes an error, just read through it, what should be the value. You guys will have this chart here. So this is, right now in this class we are using int double. And notice the boolean is isolated because it cannot be cast as anything else. But we can actually cast a char into an int. We can place smaller ones. A char is how many bits? 16. We can cast into an int, which is 32. And a 32-bit can be cast into a double. So that's automatic conversion. There's no, it automatically can be converted. When you go the other way around, that's when you're going to be losing some of, so you're going to be chopping some of the information. We're talking about this briefly in the class. And we talked about truncating, right? Read through this carefully. So, we talked about truncating doubles. And we're going to go over the ASCII character table during class. So, if you have any questions,